Okay, recap what you need to know for circle. Okay, I'm going to do a quick summary. If from the center, this is the center of the circle, what is this line called? What is that line called? A chord. A chord divides the circle into two parts. But a chord that passes through the center, what is it called? Diameter. Mervin, if this particular part, perpendicular distance, Mervin, this perpendicular distance is 2 cm, this is 4 cm. Alright, if this is also 4 cm, can you tell me what is this distance here?
2 cm.
Huh? If the chord here is 4 cm, the chord here is 4 cm. Right? But this perpendicular distance away from the center is 2 cm. Can you tell me what is the distance here? 2 cm. One useful thing that I always like you to use. Please remember, very important, the moment I join this line, what do I form?
Triangle.
What do I form? Triangle. What kind of triangle? Isosceles. Where got right angle? This triangle is isosceles. But because it's an isosceles triangle, please tell yourself you can cut it into two equal halves to form two smaller right angle triangle. Why is this concept important? Because sometimes you are given the particular radius. You are given this particular length, you may need to find it. But now in this case, I give you this and this, you'll be able to find the radius. By what method? By Pythagoras theorem. Likewise, I can also find this angle. Am I right? Once I'm able to find this angle, I can find the whole of this angle itself. Okay? So that is one portion that you need to use. Next. This is not the most important one because this one, most of y'all will have no problem. We need to know 5 other important properties. First one. Okay? This is the very first important property. What is an important feature in this before you can use the property? I said to you all last year. Okay? The 2 points must touch the circumference. Likewise, the 2 points must touch the center. More importantly, the center must be given. If there's no center given, you cannot use this. What property are we using? Okay, angle at the center is 2 times the angle at the circumference. So angle at the center is always double the one at the circumference. So please write. The one in black is the full reason. The one in blue is the feature you need to look out for before you can use it. Alright, the next one. If a diameter is given, straight away can you tell me what angle is this? 2 angle at what? I don't know. You ask the person beside you. You don't know this one? If this is the diameter meaning it must cut through the center of the circle. This angle down here must be 90 degrees. Okay, this angle down here must be 90 degrees. What is the name? The feature is it must be a diameter given before you can form the triangle. And what is the name of this property? What semicircle? Okay, angle in semicircle or triangle in semicircle is also fine. Okay, these two, center and diameter immediately. Alright, so look at the question. Is the center given? If there's a center given, there's a high chance you can use this. If it cuts the circle at the center, it means that there could be a possible diameter. You may want to use the fact that it's the angle in a semicircle. Two more. Alright, this one, what does it look like, the diagram? It looks like a butterfly. But please don't give me the butterfly as a reason. It's just for you to spot the picture. Okay? Whenever you see a pair of butterfly wings, tell yourself, this angle and this angle facing the same side are the same. Okay? Similarly, this angle and this angle, they are equal. What is the name for this particular property? Angle in the same side? No. Okay, angle in the same segment. Okay, Melvin, you can take a pass. We're drinking water. Yes. Okay, what do you see in this diagram now? What can you see on the diagram? Wei Yan? Four-sided figure is called what? Quadrilateral. If all four sides touches the circumference of a circle, there is a special name. Start with C. What kind of quadrilateral? Thank you, Jermaine. It's called a cyclic quadrilateral. But what if one of the sides touch the center? Is it counted? No. All four corners must be touching the circumference. Then, what will the property tell us? The opposite angles. Opposite, it cannot be alternate next to it. Opposite angle. Let's say this is A, this is B. Angle A plus angle B will sum up to 180. Similarly, C and D, they will sum up to 180. The opposite angles will sum up to 180. But what is the name of this particular property? Okay, it's called angles in opposite segment. But sometimes you may confuse same segment, opposite segment. There's another way. Opposite angle in cyclic quad. The second one confirm will not forget one. Okay, opposite angles in a cyclic quad. I will accept these two sets of reasons. Okay? One more. So take note. We have center, we have diameter, we have butterfly, we have cyclic quad. One more. There must be another distinct feature. Can you all remember? Start with T. Thank you. Tangent. And please put a star here because for tangent, it's very necessary when you do A Math in the second semester. Alright? What is defined to be a tangent? Touch the circumference of the circle at one point. And a tangent will always be perpendicular to what? Radius. Okay, I'm just going to put down here. Because sometimes they ask you, why is it 90 degrees? You just have to write down tangent perpendicular to radius. Okay, what is the important thing about tangent over here? From the point where the tangent touches the circle, if I'm able to form a triangle, there will be one very important property that we make use of. Okay, all look here, don't copy first. The angle subtended by the triangle as well as the tangent. Alright? The angle subtended by the tangent as well as the triangle. Tell yourself, move along the same direction. Skip the first angle, but the very next angle, these two angles will be the same. Similarly, this is also the other side of the angle that is subtended by the tangent as well as the triangle. Am I right? So move in the same direction. Are we supposed to consider the very first angle? No. Skip the first one, go to the second one. These two angles are the same as well. What is the name of this property? Thank you, Rachel. Angle in alternate segment. Okay, and there you have it. Everything listed here. So when Mr. Liu do the question, I don't straight away start solving. What I tell myself is, okay, is there a center? If there is a center, let me write out the measurement first. Is there a diameter where I can draw my 90 degree? Is there going to be a cyclic chord? Is there a butterfly for me to indicate that the angles are the same? Likewise, is there going to be a tangent such that I can indicate my alternate segment in my figure first? Then I start solving. Because when you start solving immediately, you're always very concerned with the answer. Don't look for the answer first. Indicate whatever you can indicate on your diagram first. Okay? Now I give you 2 minutes to copy first.